Today, I'm excited to introduce FlorDB, a versatile logging database that simplifies how we manage the AI and machine learning lifecycle. Let me start by explaining what makes FlorDB unique. While there are many tools out there for managing ML workflows, FlorDB introduces something particularly useful: hindsight logging. Imagine you're deep into training a model and you suddenly realize you forgot to track an important metric. Traditionally, this would mean starting over from scratch. But with FlorDB, you can add those logging statements after the fact and efficiently replay your training with the new logging in place. FlorDB is designed to integrate seamlessly with your existing workflow. Whether you're using Make for basic automation, Airflow for complex pipelines, MLFlow for experiment tracking, or Slurm for cluster management, FlorDB works alongside all of them. What makes FlorDB particularly useful is its adaptability. It can serve as your model registry for version control, feature store for managing training data, labeling solution for data annotation, and more, adapting to your specific needs. Getting started with FlorDB is straightforward. If you want the latest stable version, you can simply run pip install FlorDB. Let me show you how simple it is to start using FlorDB. One of our core design principles is having a low floor and a high ceiling, meaning it should be easy to get started, but capable enough for complex use cases. Here's all you need to log for your first message. You open an IPython terminal, import Flor, and then log message hello world. When you run this, you'll see the message hello world and changes committed successfully. And retrieving your logs, just as simple. You can use a Flor data frame. So again, from within an IPython interactive terminal, you can import Flor and call Flor data frame, asking for the message. This gives you a clean, organized view of all your logged messages. No need to set up a database schema, no complex configurations, just straightforward logging capabilities. What's particularly useful about this approach is that you can start small, logging just the basics, and expand your logging as your needs grow. There's no upfront commitment to a complex infrastructure. FlorDB grows with your project's needs. Now, let's look at how FlorDB handles real machine learning workflows. While the basic logging we just saw is useful, FlorDB really shines when working with complex experiments that have multiple hyperparameters and metrics to track. Let me show you how you can adapt your existing PyTorch training script to incorporate FlorDB logging. We'll break this down into three key parts: logging hyperparameters, managing model checkpoints, and tracking metrics. First, let's look at how we handle hyperparameters. Notice how we're using flor.arg here. This does two important things. It logs the parameter values, and it makes them configurable from the command line. This means you can easily run experiments with different parameters without changing your code. Next, let's look at the training loop. FlorDB provides a checkpointing system that works seamlessly with PyTorch. Let me highlight a few important features here. The flor.checkpointing context manager handles saving and loading model states. Flor.loop helps track iteration progress, and flor.log captures metrics like loss values during training. To view all this logged information, you can use a Flor data frame, just like before, but now with multiple columns. This gives you a comprehensive view of your experiments, showing how different hyperparameters affect your model's performance. Let me introduce you to one of FlorDB's most distinctive capabilities: hindsight logging, which is the ability to add logging statements after your experiments have run. Let me walk you through a practical example. First, let's use a sample repository to demonstrate this. You can get it by running git clone and ML tutorial from a GitHub URL, cd ML tutorial, and make install. Let's start with our first training run. We'll be calling Python on a simple PyTorch script, train.py. When we run this, we'll see output like created and switched to new branch floor.shadow. This is done to protect your Git history from automatic commits, as well as a variety of hyperparameters like device, seed, hidden, and so on that are being logged by Floor, and metrics like accuracy and number of instances that are correct. Now, let's run another experiment with different parameters. We can do this by calling Python on the same script, train.py, but we're going to set the hyperparameters with the -- keyword args flag. And you'll see that we're calling this script with fewer epochs, a larger batch size, and a smaller learning rate. At this point, we have 2 training runs in our database. We can view them easily by calling floor.dataframe and selecting the columns. Here's where hindsight logging becomes valuable. Imagine you're analyzing these runs and realize you need to know what the gradient norms were during training. A naive solution is simply to retrain both models from scratch after adding the relevant logging statements. With FlorDB, you simply add the new logging statements to the latest version of your code and replay your previous runs efficiently. Here's how we add gradient norm logging to our training script. To replay our previous runs with this new logging, we simply use python-m-floor replay gradient norm. FlorDB will analyze your previous runs and replay them efficiently, only executing the parts needed to capture the new information. When it's done, you can view the updated results. Notice how the gradient norm, data recovered with hindsight logging, is now just another column in the Floor data frame. The power here is that we didn't have to modify our original experiments or rerun them from scratch. FlorDB handled all the complexity of propagating logging statements back in time and replaying the necessary parts of our training history efficiently. Now that we've covered the core features of FlorDB, let me show you how it fits into larger AI/ML applications. In the real world, AI/ML applications need to manage complex pipelines spanning multiple components, from feature computation to model training to human feedback. Let me demonstrate this using our document parser application. First, I'll show you how FlorDB can operate as a feature store. When processing PDF documents, we need to extract and store various features. Here's how FlorDB handles this. So I'm next opening the featureize.py script, and looking inside, I can see that I'm iterating over documents, and then within each document, iterating over pages to log the source of the text, the page text, as well as features like headings and page numbers. What's important to note is that FlorDB automatically tracks the source of each feature, OCR versus raw text features like headings and page numbers, the relationship between documents, pages, and their features, complete provenance of how features were computed. All this happens without needing a predefined schema or complex setup. Next, I'll talk about how FlorDB operates as a model registry. Here, I'll be opening the train.py script, and early on we see I can extract labeled data, choosing first page and page color as features. As before, you'll see me using floor args to set model training hyperparameters, and then I define the main training loop, logging accuracy and recall. One of the most powerful aspects is how FlorDB handles human feedback. In our PDF parser application, we have a Flask interface where experts can review and correct model predictions. Let me open this web application very quickly by calling make run. You will see an overview of a few documents that I can individually click on. Clicking on one such document, I see a view where there is a layer, a thin color layer, overlaid over each individual page, and then the extracted text appears on a right pane. This allows the end user to view model predictions, in this case, whether two contiguous pages belong to the same document or separate documents, and correct any errors, improving future rounds of model training. So now that you've seen what the web application looks like, I want to show you the Flask code under the hood. So let's open up app.py and scroll down to save colors. You will see that I read in the colors from JavaScript, select the document that I'm viewing in the web page, and then for each page, I log the new page color. This will receive a new timestamp as well as trace that these data came from a Flask application, so to treat it as a kind of ground truth, and I can use that in future rounds of model training. The key here is that FlorDB maintains complete provenance of both machine predictions and human corrections, making it easy to track which predictions were corrected, use corrections to improve model training, and maintain data quality over time. Finally, let's look at how all these pieces fit together in a real ML application. Here's our complete pipeline as defined in the make file. So I'm going to open the make file of the document parser, and you'll see that I define targets for processing PDFs, featureizing, training, inference, and run. So there's training pipelines that are defined, there's inference pipelines that are defined with integrated featureization, and then the Flask application is the one that is managing the feedback. So when I call make run, before the run target can execute in make, the dependencies featureize and infer are going to be executed in order. So that's how make is a workflow management system. We've decided to manage dependencies and data flow using make, but you could just as easily use Airflow, Kubeflow, or any other workflow management system. FlorDB operates at the Python layer and adapts to your existing infrastructure, making it easy to integrate into your AI/ML applications. So that's FlorDB, a versatile hindsight logging database that brings together experiment tracking, model management, and human feedback in one cohesive system. To recap, the simplest way to get started is to install FlorDB via pip. Just call pip install FlorDB. FlorDB is actively maintained and developed at ASU's School of Computing and Augmented Intelligence, building on years of research at UC Berkeley's Rice Lab. We welcome contributions and feedback from the community. If you're interested in learning more about the research behind FlorDB, check out our papers. You can start with Flow with FlorDB, Incremental Context Maintenance for the Machine Learning Lifecycle, to appear in CIDR 2025, or Hindsight Logging for Model Training, which was published in VLDB 2021. Thank you for your interest in FlorDB. We look forward to seeing what you build with it.